everyone. In this video, I'm going to talk about how to use linear relationships. So in this topic, the student should clearly be able to represent a word problem into a table, be able to graph, and then also be able to convert it into an equation. So these four representations of same situation. So be able to write an equation, graph, create tables, and understand verbal situations. So here is a good example. Nemo's charges $7 for a cheese pizza and 50 cents for each additional topping. What is Y, the total cost of a pizza with X toppings? You might come across this situation. Most likely your brain doesn't want to calculate all this, but if you are a person who is ordering pizzas from Domino's or Pizza Hut, which are two popular places in our house, I would calculate what would be the cost for additional toppings, right? Here is a table situation, so let's convert this. But remember, in linear relationships, straight away there are some clues from word problems that you can derive to create your equations. Okay, Nemo charges $7 for a cheese pizza, so that's flat. So if you're ordering a pizza, it's the base is cheese, so you will be charged $7, and then every time you add an extra topping, okay, for each. Now that is a very important clue for your word problem. Anything that says each, per, right, those two indicate your slope, or in other words it's your gradient, or in other words it's your rate of change, right? These are all synonyms for slope. Now what is the Y? The total cost. So now you got an equation. So you should know, in linear relationships we represent the equation of a line as y equals mx plus c, where m represents your slope and c represents your y-intercept. And remember, anything that is flat rate is straight away your intercept. So that's your y-intercept, 7. What does that mean? That means it's touching the y-axis at 7. You see that? Straight away that is your 7. So that means, and then your gradient 0.50 is the rate of change. So with every increase of x value, right, there is a consistent increase in the y value. That's why it's called rate of change. And no matter where you pick 2 points, the gradient is always going to be the same, which is 0.50 in this situation. That's why straight away, without any confusion, you can say that because each value is 50 cents, your gradient is 0.50. And with this information, you can straight away create your equation. Then how to do your table? Okay, so let's do toppings as your x, and then let's do the cost as your y value, right? In between here is your process. So if you don't have any toppings, that would be 7 plus 0.50 times 0, correct? So you end up as 7. But let's say if your topping is 1, so you do 7 plus 0.50 times 1, so you end up as 7.50. Similarly, if you have 4 toppings, you do 7 plus 0.50 times 4, which ends up being 9. So this is how you create your table, x values, and then arrive at your y values. If you have the table, then you can easily create your coordinate points. So how do you write this into coordinate points? 0, 7, 1, 7.50. So on your x-axis, this flat is your x-axis, the vertical is your y-axis, right? So the numbers that you need on the y-axis can be separated by $1. Okay, so because you have a difference in the 50 cents, so create a table which will help you to plot this 50 cents easily. So when you have 0 toppings, it is straight away $7. Agreed? So that's why that's your y-intercept, 0, 7. Then when x is 1, that means for one topping you should go to 7.5 right there, 1 comma 7.5. Then you have 2 comma 8. Then you have 3 comma, that is 8.5. Then you have 4 comma 9. I think 4 toppings is way too much. That's enough, right? But similarly, this graph can model you as you keep adding your toppings, what would be the price. So if you have 10 toppings, your cost would be $12, right? This must be long time ago, ages ago. Right now, we don't get any pizza with 12 toppings for just $9. Oh, sorry, for $12. All right, guys, thanks again. Thanks for watching. But this is how we make use of linear relationships. So we have looked at how a verbal situation can be translated into an equation, converted into tables, and be able to be graphed on a coordinate plane. All right, thanks again. Thanks for watching and have a wonderful, blessed day. Bye bye.